So it's not every day you get a kicker warhorse in the workshop for repair. Unfortunately, this thing didn't have too much wrong with it. It had some vibration damage on the driver boards and it killed some components on the driver board, but that wasn't too bad, no dead fetch or anything like that. So while I had it here and it's in its repaired state, I thought it would be a cool idea to do a video on how this junk works. Especially since a lot of people won't have ever had hands-on experience with the kicker warhorse, as there are only a number of them floating around, and they're very premium, expensive, people still ask a lot of money for them, etc, etc, etc. So they are unique in the way that they create a sine wave. I haven't seen any other car audio amplifiers that work in this way. The first thing that is different to normal car audio amplifiers is that there is no power supply and output section separated. It is just one big thing, and what this amplifier is doing is, rather than creating high voltage rail voltages for an output section to then put a sine wave in between, what this is doing is it's actually oscillating a sine wave onto the 12 volts input. So it literally takes 12 volt on ground as its rails and oscillates a sine wave in Class D sort of architecture. I'll get to that in a minute. And it puts a sine wave on between the positive and negative rails, and then just boosts the voltage up to something high enough using these great big MF transformers in order to drive a speaker up to 10,000 watts. So at 12 volts worth of sine wave, there is horrendous amounts of current available, and after you've stepped up the voltage, then you know, the voltage is then increased and the current is decreased. But yeah, really interesting design. Now, the thing that I said, this is not like a normal Class D amplifier. It's not a Class D in the sense of the word. The way that this creates a sine wave is it actually splits the sine wave in half, and you'll get to see this on the scope in a minute, so hang around. What it's doing is it's taking the bottom half of the sine wave and the top half of the sine wave and splitting it down the middle. One side of the amplifier deals with the bottom half of the sine wave. The other half of the amplifier deals with the top half of the sine wave. And they don't merge them back together. Literally, on the outputs, you have voice coil number 1 and voice coil number 2. If you scope voice coil number 1 on the scope, all you see is the bottom half of the sine wave line, bottom half line, bottom half line. And on this one, all you see is top half line, top half line. So that's why you can only use this amplifier to drive a dual voice coil subwoofer. So in a regular subwoofer voice coil, do I have a spare one up here maybe? There we go. Let's take this little bad boy for example. So with a regular amplifier and dual voice coil subwoofer, your wires here are connected to the amplifier, and both coils on here receive a full sine wave, and both of these coils will be working at the same time as each other, and you'll have the same sine wave on both voice coils. However, on the Warhorse, what you're doing is you're asking one voice coil to pull the cone in, and then it stops working, it turns off, and then the other voice coil pulls the cone out, like this. So side 1 of the amplifier is doing this, and side 2 of the amplifier is doing this. So as a result, both voice coils never work at the same time. There's always one that's on and one that's off. Now, I'm sure many people will be thinking about the tiny differences in that compared to a regular amplifier. Having one voice coil off for half of the cycle, does that improve cooling? Maybe, maybe not, but it will be minimal either way. It's just a different way of driving the dual voice coil speaker, splitting the sine wave in half and asking the two voice coils to do separate things, one push and one pull. I'm sure there have been instances with the Kicker Warhorse where people haven't realized this. They haven't maybe taken note of voice coil 1, voice coil 2, hook this up, maybe hook this one up to one woofer, hook this up to another woofer, and it'll just sound like junk because each woofer will only be receiving half of the sine wave. Now, those audiophiles and people that actually respect proper music and decent sound might be thinking, damn, this is some hella crappy way of creating a sine wave, and you'd be right. If you actually listen to the subwoofer up close on this amplifier, it sounds terrible. It sounds distorted because there is an audible gap in the sine wave. There's an audible like pop between where the amp switches from one side to the other side, and many people think this is a fault, and it's actually not. This is how the amplifier works. Right, so enough chit chat. I'm going to actually show you this on the scope screen now. These amplifiers, just another note, you cannot run them with a signal without dummy loads or some kind of load on the speaker outputs. It goes bananas if you try. So always run these amplifiers with a load connected, either a dummy load if you're not running it in a system, just on a bench, or with your subwoofers connected. Never leave subwoofers disconnected from this amp and power it up. It does not like it. So we've got a nice safe lower voltage of 10.4 volts. It's better with this low current bench testing. It's safer for all the components. And we have a 38-ish hertz sine wave on the signal generator. Now watch what happens on the scope. Okay, sine wave is present. Now, at first glance, you might think, oh, it looks like a pretty normal looking sine wave. But hang on, there's a line in the middle. You don't usually have this line down the center. It's usually just a nice sine wave. And the reason you've got this line down the center is if I remove one of the channels, I've got my two channels hooked up to voice coil 1 and voice coil 2, you can see there that channel 1 is just the top half of the sine wave. And then channel 2 is just the bottom half of the sine wave. And you can bring the two apart so you can see exactly what I mean. There we go. So there is a cut-off there between the two sine waves, and that is audible through the woofer if you put your ear close to it, or if your subwoofer can produce sort of high-ish kind of frequencies, you'll be able to hear that. Whoop. So yeah, pretty interesting amplifier design, and as far as I'm aware, these guys are the only ones to do it like this. Let's zoom right in on that crossover point there. So you can see that, yeah, it's not directly smooth. There is a small gap there. So yeah, that'll definitely be audible. And there's a little ramp up there. It's not quite perfect. And you can also see there's some Class D sort of noise coming in there. See that frequency? That's what frequency this is kind of oscillating at to create the sine wave. It's building up in steps like that. You can see that on there. So yeah. I mean, for driving a subwoofer in an SPL application, that's perfectly fine. You're not going to notice any different. It'll get loud, it'll sound fine. But yeah, not for your SQ head type applications at all, no. Other things to mention real quick, I mean, build quality wise, very impressive. They're actually built pretty well. Yeah. Not really going to struggle from any sorts of vibration damage. Everything is seated down nicely, apart from this one did suffer from vibration damage on the driver boards here. And it snapped the legs off, and it killed a couple of the chips on these driver boards because they weren't being fed with the correct signals and VCC, etc. And the amplifier went in some kind of weird trippy mode, and it killed a few of the components on here. So yeah, build quality wise, the only issue I can see here is these are not really suited to vibration very well. Other things worth noting, this has a pretty sophisticated protection circuit. It has. You can see it's going to tell you whether it's protecting from under voltage, over voltage, over temperature, short on the output speaker terminals, or if it detects another short inside, some problem with the amplifier itself, it'll throw the service light. And it's all controlled by DSP chip. So yeah, pretty cool. So there you have it, quick little rundown of a Kicker Warhorse. This is a super speedy quick video because the customer's actually coming to collect this tonight, and I thought, oh, I should do a quick video on this while I have it in the workshop, and so I had like half an hour to just quickly bang this out. If you have any questions about the Kicker Warhorse, want to know a bit more about how it works, feel free to leave me a comment, shoot me a message. Yeah, until then, I'll catch you next time for some more amplifier related videos.